כן. אגיד לכולם שאני עכשיו עוברת לאנגלית. יהיה בסוף ההרצאה של אדריאן קוד ה-QR שתוכלו לסרוק ולשלוח את השאלות. מבורך אם יהיו באנגלית כבר ורק נקריא אותם. אז אני עוברת לאנגלית. How do we bring landscape back to life? שנייה, How do we bring landscape back to life when the landscape is a city? Adrian McGregor, co-founder of McGregor Coxall and global pioneer in landscape and urban innovation, invites us to rethink the boundaries between nature and built environment. Through his visionary concept, BIOURBANISM, he asks, what if cities aren't separate from nature but part of it? In this talk, McGregor explores how urban spaces can become active participants in climate resilience and ecological renewal. He offers a hopeful, radical perspective. The reviving landscape means also reviving cities, and that thought, nature-created design, cities can become part of the solution to our global environment challenges. Adrian, please.
Thanks so much for the introduction, and it's wonderful to be here in Israel. I've had a very, very interesting week this week, touring parts of Israel. I've seen some of the landscape. I've been to Haifa, Jerusalem, and to Tel Aviv. And the fascinating thing that I've kind of learnt about the landscape here is that there are many similarities to Australia. We also have a very dry continent. Most of Australia is desert, so we live on the coast. All of our population and our cities are right on the edge of our country. The thing that I think is very interesting between our two countries is this concept of landscape. And as landscape architects, clearly this is the territory that we work in. In Australia, we have an occupation of peoples, the First Nations, Aboriginal people, who have actually lived on country for 60,000 years. And what they are teaching us in Australia now about our understanding of landscape is the concept of land, water and sky, and how these things unite all of us around the world. Sorry, just to work out this slide. So this concept of landscape is really what has driven our practice in our firm. So what we do is I think that our firm started off working on very, very small projects. And over the years, we kind of expanded our scope, and we really tried to push landscape architecture into bigger and bigger scales. And the culmination of that is really being fundamentally interested in cities themselves. So our firm is a master planning firm, and we're very interested in data intelligence and also how we use kind of research in that. This is strange. Okay, so the company is about 27 years old. I actually founded it myself, and now we are a multicultural team, more than 20 cultures. And we're kind of working around the world in many different places and environments. The way that the business is structured now is that our master planning services are kind of underpinned through landscape architecture, sustainability and climate services, but also this research lab that we set up, which really is the culmination of the work that I'll talk to you about from the book that I wrote. So BIOURBANISM is a concept that I've worked on for my whole career. It's been kind of an evolution of thinking. And really, it's actually in COVID that I finished this book. It took me probably 15 years to write it, and I worked, as we all are busy in our practices and you know, trying to manage multiple things. I kept working away at this in the background and actually changing my view over time. When I first started the book, when I finished it, it was a whole journey, a personal journey for me. But I finished it in COVID, when we were all locked in a room and we couldn't move, and actually, you know, kind of in that space. So I actually had the time to finish the thinking and to complete this work. So the book is about cities, and really it's a call to action. And what I'm kind of asking in the book is that we need to fundamentally rethink what cities are, and actually think about them as the solution to the climate emergency, which might sound a little bit strange, but I'll explain that. What we have now on planet Earth is more than, we just tipped over the 8 billion mark. And Homo sapiens, us human beings, we are an animal, we've created more than 10,000 cities globally. And it's an incredible thing that we've made. So most of us live in these places, and they are our homes. But as time goes on, the challenges that are facing our cities and human beings, or Homo sapiens, across our planet are growing. So cities themselves, incredible as they are, we are still growing them. So by 2030, there's going to be another 10 megacities across the world, cities of more than 10 million people. And most of those are growing rapidly in the equatorial belt, places where we have a lot of heat and incredible population growth. So that's bringing a whole series of challenges, but also it's bringing opportunities. And I think landscape architecture globally has a role to play in shaping cities and getting more involved in the conversation about what we want our cities to be in the future and how they support us and how they are part of nature. Incredible statistics here. There's 150 million extra elderly people that are going to need to be looked after in our cities by us. There's a huge change now in manufacturing. We're starting to see AI move in to automation. So we are in this phenomenal period of change in our cities and our landscapes and our urban landscapes. And that is going to be something that presents a lot of opportunity for us. So if cities are the cause of climate change, then they must also be the solution. So currently, cities produce 75% of all of the world's greenhouse gases. So cities create climate change. They create carbon output. 70% of cities today already report that climate change is impacting them. And then more than half of us, 55 and moving into 60% of us, actually live in cities already. So I'm just going to unpack now some of the chapters, the 4 chapters in my book, and I'll explain the thinking around biourbanism and how I kind of evolved this concept. So first of all, I talked about the rise and fall of cities. And interestingly enough, right here, ancient Jericho and Catalhoyuk is two of the most ancient cities going back to the kind of Middle Stone Ages. So I traced the history of cities around the world, and I looked at the culture and the technologies that drove the growth of cities over time, and it ends up all the way today in the Anthropocene. So just recently, science has decided that we now have entered a new epoch, and the epoch is the epoch of the human being. It's of the epoch of the Homo sapien, the Anthropocene. So this incredible journey of cities has been driven by factors that are kind of common, if you like. So fertile soils, water, provision of food, governance, All of these things have supported cities over time, and in fact those that have survived and been resilient over time are those that have been able to be continuously supported by those things. The cities that have fallen often are due to climate change. So civilizations and cities have collapsed because rivers have changed course, desertification, changes in rainfall pattern, the fundamentals that drive our ability to live in cities. So there are 10 urban epochs that I trace through that period. Then chapter 2 moves into what I call the converging emergencies. And these are things that are really challenging and facing cities. The biggest one at the moment is the continual increase in urban population. So if you look at this graph here, you can see Asia and Africa, the pink and yellow colours in the top of this graph. And this is out to 2050 being the places in the world where we're seeing cities grow. And that equated to that mega-city drawing that I showed before. So these are increasing in population, and this is going to present, increasing challenge for existing cities and those new cities. So I talked a little bit about the carbon footprint of cities, and it's important to realise kind of what those drivers are. So this is describing where those carbon emissions are coming from in the city footprint. So the biggest one is industrial emissions, and that's through things like stationary energy. Then transport emissions, and then emissions that come from buildings, like places where we are, right here today. And then in smaller amounts, agriculture and some of those other things. So really we've got to make fast and deep impact on these major 3 areas of cities in order to drive down carbon emissions and to bring down or try and stabilise global warming. We have already reached 1.5 degrees of warming, and that warming is continuing. There is no slowdown in it, and some of the scientists are predicting that we'll get to +6 degrees if we continue on the current trajectory, which clearly is really problematic. When you look at cities, these white circles are representing the entire carbon footprint of some of the largest countries in the world, or a snapshot of those. And the bottom is China and the US. And in the 3 circles in the centre, that's the carbon emission footprint of the 3 largest cities. You can see South Korea right on the top there, Seoul being kind of almost 80% of the total carbon footprint of the whole country. So we're starting to understand more and more about these emissions. And let me see. So this is incredible graphic simulation that was done by NASA only a few years ago. What it's showing is an annual carbon emissions globally. So carbon is getting pushed out of our cities and it's getting trapped inside the troposphere. The troposphere is that very thin ring that's holding all the gases that obviously keep us alive and our planetary systems in place. On the bottom you can see those green lights that are kind of flashing in the bottom, the green dots. That's the forests trying to sequester that carbon as it's emitted. They're trying to ingest it to create oxygen from the carbon dioxide. But clearly what's happening each year is that we are emitting too much carbon, and our ability for forests and actually the ocean to sequester that is diminishing. So these carbon emissions and these city carbon footprints are creating a whole series of challenges for cities all around the world. And these are impacting various cities depending on their sort of territory and their proximity to whether it be extra desertification and urban heat, or whether it be flooding and sea level rise. There are a whole series of these that I talk about in the book. But what is really starting to emerge now, and what we're starting to see, is this concept of climate risk. And by 2050, the CNEP says that there's around $158 trillion of global assets at risk from climate change. So on the right there you can see UK property risk from a talk I did in London, but there's around 500,000 properties already that are impacted by climate risk, and that's going to grow to an estimated 2 million by 2100. So the insurance industries are right across this. When you apply for an insurance policy now, the insurance companies have got huge databases. They plug your address in, and they will call all of the data around simulation and forecasting for climate risk when you apply for that policy. There are some places in Australia now, we've had 2 floods in one small city on our east coast, 3 months apart. Both those flood levels exceeded anything that has ever been seen before. The consequence of that is that the government has had to fund hundreds of millions of dollars of repair work just for that particular area. And if you live in that small city, you cannot get insurance for many properties. So now you are carrying the entire risk of your property. If it burns down, if anything happens to it, another flood, you can't receive insurance. This we're going to see more and more as things like the California wildfires we saw there. Again, some of these things that are coming at us, extreme events that we've never seen before, and the consequences are growing. So I've taken some information here. Our lab, our biolab, ingested this information from the IPCC, and there are 3 slides here I'll show you. The first one is from 2006, and these are coastal temperatures on the east coast of Australia. Going forward to 2023, you can see this map with temperatures increasing. This is between Sydney and Brisbane on the east coast. And then this is the prediction for 2100 based on the worst case IPCC scenario. So we're seeing temperatures in some of our major cities go to 40 to 50 degrees, which is an increase of kind of 10 degrees or more on what we see today. So these are really, quite confronting metrics. And what it means is that we can't design our projects today for yesterday. We need to be looking forward and making sure that how we design is suitable for this environment that is changing very, very rapidly, and that we're thinking as landscape architects and planners and urban designers around how to deal with these things. So if you think about design, then the environmental crisis that we have is a design crisis. We have designed and engineered our cities. We've created them. So therefore, the conditions that we face are a result of potentially our poor design decision making. We're trying to repair as much as possible, but we need to think more boldly. So biou-urbanism is the concept or the model that I created to try and or as a framework for trying to understand these planetary drivers, and then how we can think differently about our cities to better or create better outcomes for ourselves and for our environment. So what I did is I looked at some of the new planetary science, and importantly, when you look at nature and you look at ecosystems, we are a mammal, so we are a species, Homo sapiens. We exist inside a network of other species, and we rely on those species to survive. But we often seem to think that we sit on the top and everything is below us and it's a resource for us to ingest and use, and that's kind of a real problem for us because it's having huge consequence. So if we look at, and we all would have studied ecology and environmental science in our degrees, so looking at the hierarchy of living things, starting at the cellular level and going all the way out to the planetary level, which is the biosphere at the highest level, and then the troposphere around that. What's happened in the Anthropocene is that the wild biomes, which are the second largest category here, that we would understand as forests, deserts, tundras, these kind of grasslands, these kind of places that were classified or had an ecological or environmental classification. They now are almost barely recognisable from their wild condition. So we would have learned about them as wild places. but we've had so much impact on re-engineering them that they no longer exist in their wild condition. And there were two ecologists, Ellis and Ramankutty, who coined this term anthrome. And the anthrome recognises the impact that we have had on these wild biomes. So if you're looking for a wild biome, you need to look to the north and south poles to see some of these things that are, potentially still in their wild state. Everything else has been altered by us. It's unrecognisable from pre-human condition. You can see the purple and the blue intense colours here. They're the areas of greatest urbanisation density in the world. So what I've taken from this kind of recent ecological research and the planetary science is to say that the anthrome is actually is a city. So we have altered nature, but cities themselves have to be nature. They can't be anything else. We are nature, and what we build is still part of nature. It's still on spaceship Earth, on planet Earth. There's nothing else that it can be. And as an example, I use this where we look at a termite and we say that on the termite, we call that nature. So the termite city it's actually a phenomenal bit of engineering. It has temperature regulation, it has a hierarchy of rooms, there are different not cultural, but there are different, worker ants to queens, to all of these different occupations that sit inside this thing. And we call that nature. But then if we look at, on the right, the buildings that we build in our cities, we somehow say that's not nature. So it's not possible. They're different forms of nature, but they're both nature. And they're both produced by, the city's produced by us, and we're part of nature. So I think this is where we really fundamentally need to make a shift. And I think that architects, urban planners and engineers need to probably take more advice from landscape architects around, understanding these systems, because the systems drive everything. You can't look at a building in isolation and not think that it's deeply connected to our environment. So the BIOURBANISM model then is, I tried to create a kind of simple framework. There are 10 systems. There are 5 biosystems and 5 urban systems, and that frames the word BIOURBANISM. So the 5 biosystems are citizens, food, landscape, waste, and water. And then the urban systems are economy, energy, infrastructure, mobility, and technology. So through those 10 systems, we can understand how cities function, their metabolisms, and also their performance. Are they healthy? Are they unhealthy? Are they performing well or poorly? So from there, I took those 10 indicators, those 10 systems, and I set up a series of indicators that sit below. And these two diagrams show, on the left are the city indicators, and on the right are the place indicators. And they're ways of kind of checklists, if you like, for understanding how places and cities are performing. And then what I did, all those lines that connect all of those systems, I actually mapped out the interrelationships between them. So it's illustrating how connected cities are and how these processes are interrelated and impacting or making impact on one will have a flow-on impact to another part of the city. So from there, I wanted to, as a practicing landscape architect and doing design work and projects, I wanted to make sure this wasn't entirely theoretical and that could be actually applied. So we created a BIOURBANISM lab, and we have an interesting range of academics that we brought into the firm, and some of them are PhDs. They have different ways of thinking from landscape architecture. They bring a different kind of brain. But what is really great is engaging with their kind of scientific brain and kind of mixing that with the design methodologies. And what we did is we effectively have started to build out a set of tools across each system. Some of these tools already exist. Some of them are new tools that we're building. But all of these are divided up and kind of categorized into these 10 systems, which is sitting inside that larger framework. What we're doing is we run these tools inside digital twins. And from the digital twin, we're then creating what we call key performance indicators or KPIs, and then looking at dashboards that are actually helping you understand how something is performing. And this can be done either at city and increasingly at place level. So the thing that I find really interesting, I've always been fascinated by technology and data and how it has kind of moved into our work. I was telling someone this morning, I still model myself, I 3D model on the weekends and at night. Fundamentally, I'm very interested in this. And seeing AI now and how it's coming into what we do is unbelievable. It's incredible how these things are starting to empower and inform our work, and we can use this to do better design. The digital twins are amazing because they're a sandbox. You can play around in them. So you can take a design, you can drop it into the twin, and then you can test different outcomes and scenarios, which I think is really, really interesting. So we're starting to do this now with quite a few clients, different places around the world. So we're building digital twins, and clearly the first, in terms of city digital twins, buildings have come first. So we've come out of BIM, if you like, and building, models that understand an individual building. But as landscape architects, we're interested in, the full landscape and the whole city. So we can now ingest all of these buildings inside a much bigger model and start looking at the wider implications across the whole city. So we've been using this in projects in the Middle East, in the region, and using it for master planning, where in this case, looking at very large areas, kind of 40 kilometres of area, but very early getting things like GFA and other metrics and population, for example, out of these early digital twins. As an example of some of the tools that we're running in the digital twins, this is one, it's a pedestrian model. So this is actually taking phone ping data. So you can buy these aggregated data sets, which are anonymized, and you can understand in your city at any point in time, on any day, where people actually were. Very, very powerful for your urban kind of planning, urban design work, especially related to retail and streets and squares. But incredibly powerful information, and you can see here a data set for the whole of Australia, which we then zoomed into Sydney, and then we zoomed into our project site. You can also understand where people have come from, their destination origin, and these big data sets you can actually work with to get unbelievable information that informs the intelligence of your design and planning work. That can then be used for simulations as well, so you can start to take existing data and then apply design forecasting to go forward. We're using it for things like greenhouse gas emissions in building stock, and then this is an example of a digital twin that we built more at the kind of regional centre scale. You can see on the top the systems switching on and off. And so what we've done is we've taken these data sets, we have then checked them and then imported them into a geospatial model. And this is creating this incredibly powerful model of the whole city that then the government uses to be able to do design scenario testing. If you want to add density, you want to make changes, you can start to model the impact of these changes inside your model. So things like, in this case, open space proximity, and in the last presentation, looking at the green grid of Tel Aviv, for example. So very powerful ways to test what's the proximity of people's homes to their local open space. Are there gaps? Does everybody have equal access, or do they not? Very powerful information for planning new space to try and make more equitable places. This is flood risk analysis. So as I mentioned, we're seeing flood levels that are increasing. So engineers need to start to look forward and not rely on past models, but start, ingesting or start working with future models that take climate into consideration. This is an urban heat tool that we created. So you can already take drone information, LiDAR scans, infrared scans, and you can create a heat map of your city today. But you can also, or what the lab has done is we've worked out a way to forecast heat. So we assign temperatures and libidos to various surfaces, and then we can run a desktop forecast. So we can understand in a design where heat is likely to be. So that is the kind of the framework of the model. And then what I wanted to do was say, look, landscape architects got a huge role to play in resilience. So I wanted to look at how can we take our design and planning services and change cities for the better, so that we can reduce the risk to all of us from things like fire and sea level rise and all of these other issues. Depending on where you are in the world, the issues are different, whether it's developing or mature economies. But resilience, obviously, and we've heard a lot today about, I think, around personal resilience and emotional resilience. But at the city level, some of these things are important. I spoke a bit about insurance, about redundancy in an event, about repair, many of these things that have been in the conversation today. And then in the book I outline 10 steps for how to build a resilience plan. And I'm really surprised that cities around the world are not taking this more seriously. Since I wrote the book and I'm kind of monitoring, there's a slow uptake. For some reason, our governments and our city leaders are not really pushing and driving and building these plans so that we're ready, and we're prepared for these kinds of things that are coming. And then seeing behind when you're building these plans, it's all about looking forward at the KPIs and then developing your targets. So each city has a different set of priorities. What is it that you want to be most involved in terms of creating future strategy? So from there, what I'll show you now are some projects, and it's important, as a design practice, we love design, and these things running in parallel, research-informed design is really what is driving us along in terms of understanding data and using the science that is around us. There's a huge amount of information for us to access, both in the public space and private data. So at the very largest scale, I've been lucky enough to be involved in the design of 2 new cities. This one is in Shenzhen in China. But the fundamentals that underpin this are walkability, public transport, and then leaving the landscape systems alone, giving them the space to continue to function. So compact, dense footprints that minimise, or that are located on areas with the least environmental impact. Then, as one way of looking at this, I work with an economist, and we looked at that city model, and what we did is looked at one productivity measure, and it was around sort of worker sickness, if you like. So the city model, because of the health impacts that it has to its inhabitants or citizens, they would be at work for longer, so less sick days. And that means the city's more productive. So it was around $8.5 billion over 40 years, just on that one measure alone. So it shows that the work that we do in landscape planning and nature-based solutions does have economic impact. And this is something we have to get better as a profession at demonstrating. We need to be able to go back to, our government economists and say there is measurable economic benefit to the things that we are creating. And I think this is starting to move in a very interesting direction as well. Because often they'll look at what we do as a cost and they'll say, oh, you want to build a park, you want to build, community infrastructure. That's a cost. Well, yeah, but what about the benefit? So we need to get better at that. And I think that we are. The other city that I've been working on for the last kind of 6 years is the Line at Neom, and this is really a very radical project. I'm sure that many of you have seen it, but it's a 170-kilometre long city for 9 million people, and it is really revolutionary. It is taking all of the most innovative ideas in urban systems from around the world and embedding them into this completely revolutionary city, which will redefine what cities are and how they work. It's really a kind of a laboratory for a whole lot of innovation. Interestingly, it's car-free. It's 100% walkable, and it's underpinned by high-speed rail, metro, and 100% renewable energy as well. But it also, the entire region of Neom is fascinating. It's an amazing desert environment, highly biodiverse. And actually, we did the master plan for the region. So it will be the 6th largest national park in the world. And it's already having a process of rewilding, they're reintroducing species that have been lost. But importantly, 95% of the region is preserved, and the city only occupies 5% of the footprint. So that very dense footprint is ensuring that the environment is maintained and protected. We've also been working inside the line, and these are images that have been shown publicly, but the incredible height of 500 metres and the urbanism inside is unprecedented. So we've been working on kind of 2 million square metres of public space inside the line and shaping the framework for that. And it continues to be an incredible project and journey for us. Some of the other work we've done in terms of urban planning and nature-based sort of solutions is in China, looking at, again, the same principles of how can we retrofit, in this case, coastal areas and create better cities. This is an example from the UK. It's a small city in Bristol, which is kind of about an hour from London. And this is the public estate. So it's the city government of Bristol, and this is their boundary. And inside this boundary, they have ownership of a lot of assets. They own parks, community centres, libraries, buildings. And what they wanted to do was look at the climate risk to all of their portfolio. So that's one example of a progressive government saying, okay, let's look at our assets, let's look at the risk that is coming in climate change, and let's create priorities for how we want to manage these things going forward. Then a project that you might have seen, Ballast Point, it's one of our more famous projects, but this was an old contaminated site on Sydney Harbour. It had around 100 oil tanks on it, and it was heavily polluted. So the whole soil, all the way down to rock, was embedded with hydrocarbons. And so what happened was that we took all of the soil off the site, and it was cleaned off-site. And then there was a new master plan that was created to bring public access back and to regenerate the site. So what we now have is quite a beautiful park that is evolving. The thing that we did here with the vegetation was that all of the seed that was effectively collected for all of the trees and the species was local. So we're using local DNA from this part of the harbour to actually regenerate it. So it's very, very kind of specific, if you like, to the nature in this part of the harbour. It's quite a wonderful place now. It's a great place if you come to Sydney to look at the fire